So indeed, today, I'd like to present a number of tools that I use all the time, I find really cool, and that I think might be worth having a look at. At the very end, I'll talk about 2 Emacs tools, so non-Emacs users can leave at that point, but I'll keep that for the very end. Everything else is very general and I think could potentially be useful for anyone. So the very first one I'll talk about is called LazyGit. The repository is here, again, linked from the chat. And as you can see, it has a lot of stars. It's actively developed. Those are very good signs on those open source projects. And what it does is that it allows, it kind of gives the best of both worlds, because Git is this extremely amazing, powerful version control tool, but it's not exactly visual, and there's a lot of comments that are kind of a little bit clunky to use if you want to, for instance, stage part of a file, or it's not always very convenient to do everything from the command line. So there are very many GUIs that have been built for Git, and they're all pretty nightmarish, in my opinion. They are very slow, they're not portable, they're very limited. So I'm really not a fan of that. And LazyGit, I think, is fantastic because it kind of brings the beauty of the visual of those GUIs, but inside the command line. So it's just as fast as typing command in the command line. It's super portable. So I'll show you what it looks like. So this is a Git repository that I use when I teach Git. So it's got all sorts of silly stuff in there, and it's a pretty good one to demo LazyGit. So I just type LazyGit in the command line, and it opens this user interface, but I'm still in the command line. I can quit it instantly, and I haven't popped up any GUI. So that's something that if you were, for instance, working on a computer cluster from Compute Canada through SSH, you wouldn't need to pass the menace capital Y flag, and you wouldn't have the slowdown of a big clunky GUI in the system. I am still in the command line. Sorry. It's very similar to all those end cursors user interface that are built for the command line. Okay, so what do we have here? This is my repository. This is the branch, the remote branch that the current local branch I'm on is pointing to. This first box here gives the status of my local repository compared to the remote. So I don't know if you can see on the shared screen, but there's a little up arrow here, and it means that I am 1 commit behind the remote. So I need to git push if I want to be in sync with the remote. And there's a little down arrow here with a 0. It means that I have nothing to pull. So I don't have to run git status to see where I'm at with the remote. It's already in here. Then I have here the other information that you normally get when you run git status. I have the various files that have been transformed, and I can by default the command lines, the key bindings are very Vim oriented, but they are totally customizable, so you can make them whatever you want. But it's very Vim like, so J to go down, K to go up, that sort of things. And here you have the result of git diff. So as you can see here, okay, I have this modified file, and here I have the git diff, so I see what changes I've done. If I go down to other files, okay, this one is another modified files, I instantly view the diff. So I don't have to run git diff this file, git diff that file. I can just browse my various files and see the diff. there is mouse functionality. Here you can see I'm using the mouse, but you can also do it from the or from the keyboard. So this is a file I deleted. There are all sorts of shortcuts, etc. Here, there are the various branches. So you can see, thanks to that little star here, that I am currently on the main branch, but there are a bunch of other branches. And here you can see, this is the equivalent of git log. So you can see the whole git log with the graph flag, because you can see the various branches. And so you can visit the various branches. And here you have the commits. So this is my commit history with the hash, the author, the top line of the Git message. And then as I browse my various commits, I can see here the full output of that commit with everything that has been changed. The summary at the top with the commit message, and then the full info. And here again, I can navigate things either with the mouse or with the key bindings. Now, if there is a line that is too big and I cannot see it in the full screen, I can also change the number of windows that I see. So here I have a single window, here I have 2 windows, and here, which is the default, I have 3 windows. So I can quickly zoom from the various settings. Okay, so that's very cool to visualize things, but it's also really cool to do things. For instance, let's say I want to change branch. Oops, sorry. So I go to the branch section. Now I'm on main. If I want to check out this branch or switch to that branch in the new Git vocabulary, I just press enter here. I'm suddenly, oops, sorry, no, it's a space bar. Sorry, I press space bar. And I would change to that branch. Okay, but now I'm getting the error message that I would get from the command line if I had tried to switch to that branch, because I haven't stashed the current changes. And so in Git, if you have a bunch of changes on the branch, you can't switch to another branch, otherwise you would lose those changes. But LazyGit is really nice because it's offering me to auto stash all those changes so that I could switch. So, okay, let's do it. So enter. Okay, now I have some conflict. Boom. But now you can see that on stash, now I have some, I have auto stashed some, all those changes. Now let's go back to main. Okay, I can't. So there are a couple of commands that I still prefer doing from the command line. For instance, git, let's see. Yeah, I'm gonna do a git reset. Okay, well, this is not exactly convincing because I shouldn't have changed to that branch. But so I'll deal with that later. But let's show other functionalities to try to be a bit more convincing. If I go to one of my change files, if I press enter, I can navigate the file and I can stash. Yeah, okay. So I'll interrupt LazyGit now because we have so many tools. I'm worried to run out of time. But at the end, I'd like to go back to this and show something a little bit more convincing, because I changed to a branch and I created conflict in this very complex repo. And now it looks very messy. Well, I normally use it all the time and it's normally very smooth. So this is not very convincing. So let's move on. I'll go back to that. Another tool that I want to show you is BAT. So BAT, also very many stars, also very updated. It's a bit of a pun. It's a cat clone with wings. So it's an improved version of cat. Cat is the standard Unix command line utility that allows you to output the content of a file on the command line. And this does the same thing, but with a number of really cool improvements, including syntax highlighting, amongst other things. So let's, for instance, have a little look at all the languages that are covered for the syntax highlighting. As you can see, a ton of languages are covered. For instance, let's see, I use Julia alphabet. Let's look for Julia. Okay, yes, Julia is covered. Great. So that means that whenever I will run BAT instead of cat on a Julia file, I will have automatically syntax highlighting specific to Julia. So I have this file in my system, and this is the cat default Unix utility. It outputs the content of this file. Okay, now if I replace cat with BAT, this is what I get. So it prints the file name at the top, it prints its size. Now you can see there's syntax highlighting. So the comments are in a certain color, the digits are in another one, the strings are in another one, the keywords are in another one, etc. I have the numbering, so that's cool. Okay, but that's not the only thing. It also automatically pipes the output into less. Less is another Unix utility that allows you to scroll through some document one screenshot at a time, or to do some searches. So, but it uses less with the default options, capital R, capital F, and capital X, which is very convenient because less with those options automatically exits if all of the content fits on one screen, and remains inside the pager if you need to scroll through it to see multiple screens. So that's the behavior of the other utility more. So let's add some example here. I have another file that is this one. So here now, this is a Python script, and I'm gonna run it with the standard utility cat. So I'm running this. Okay, so I've output the whole file, and because it's a longer file than the first one I demoed, now I can't see the entire file. I have to scroll up, which can be awkward. And if it's a very long file, the terminal, and depending on the terminal and your setting, that can be different, but terminals don't have an endless scrolling history. So if you have a very long file, not only it's awkward and unpractical, but you might not even be able to see the entire file because you may not be able to scroll through the entire file. So this is not super convenient. So instead, of course, I could use less. So if I use less, now I can see the first screen size worth of document, and I can scroll. I can also do some searches, for instance, random. Okay, random is over here. Okay, so less is nicer than cat in that it allows me to scroll through the document. But now let's use that. I have the syntax highlighting, and I have the behavior of less. So I can scroll, navigate it, I can do some search exactly as I would with less. And because it's under the hood, BAT pipes to less, it's the exact same commands that you use with less. So it's all all very, you don't have to learn some new tools or any such thing. Now, what is all the more convenient is that remember how when I used it with this little Julia script, if I were to use less with this, okay, this is nice, but there's nothing to scroll, so it all fits in one screen. So now I'm in that pager. I need to exit it with Q. When I exit it, it disappears, so I can't see it again unless I rerun the command. So less, which doesn't exit automatically, is not all that great. You have to pass the certain flag to have a behavior that is more sensible. But remember, when I used bat, automatically I exited less because it fits on one screen. So bat basically gives you the functionality of the pager with really sensible options that less doesn't have by default, and has a nice visual color highlighting. So it's really cool. Now, if you want to reduce maybe you don't like this, all these, we'll use test. I'll use this one. Okay, maybe you don't like to have all this clunkiness, and maybe you want something a bit more minimalist. Well, then you can run it with the -N option, and it removes the windows. You can run it with the -P option, and it removes the windows and all the numberings. You can even have, but I don't see why you would want to do that, but have double P, and then it will even exit the pager automatically and have the same behavior that cat would, except for the color highlighting. So the defaults are nice, but you can really change them as you want. You can also, well, actually, let's rerun this one. Another thing that you will notice is that, yeah, okay. Well, no, it's, okay. I wanted to show you the Git integration, but of course, that file is one of the files that I messed up with LazyGit, because now I'm not on the right branch, so there aren't any changes. So, but you can see on the slides that if there were changes, if I were on the right branch, you would see some little symbols that show where you have additions, deletions, modifications. And if you run bat with the D flag, which stands for diff, it will show you the diff. So here, of course, I don't have any output because this file on this branch doesn't have any modification. But if I were on the right branch, I would have the diff output in bat. With the -F, you can force the syntax highlighting even if you pipe it, because for instance, if I run this, so the very basic behavior of bat that looks like cat, and I pipe it in more. I could pipe it into less, but it's kind of weird to remove less and then repipe it. So I'm piping it into something else. You can see that suddenly I've lost the syntax highlighting. But if I add the -F for force flag, now I keep the syntax highlighting even though I'm piping it into another command. So actually in my, the equivalent of my bash RC, I have an alias that my command bat stands for bat -F. I have this by default. So bat is really super cool. And you have all these commands here. You can also change the theme. You can see very many themes, lots of fun colors. So you can create a configuration file and change the theme and change a number of default behavior in that file. So that is cool. That's the key point. Another tool is ripgrep. So it's a bit of a pun because ripgrep is a tool that provides the binary RG, and RG is for recursive grep, but RG is also a bit of a pun for ripgrep because it intends to be a replacement for grep. So, and to be fair, it is really much faster for recursive searches. If you don't want to grep recursively, grep is actually faster. So I don't recommend it in all circumstances, although you could, but if you're really obsessed about efficiency, grep is actually more efficient if you are not recursively searching into subdirectories. But if you are doing any recursive search, ripgrep is really much faster. So the syntax is very similar to grep, and we will try a little benchmark just to show that in the recursive setting, it is faster. So I have this directory on my machine, and I will look for the word Unix in it. So the grep command, because it's recursive, would be grep -r. Unix is what I'm searching, it's a pattern, and then I have the path. With RG, because RG is recursive by default, I don't need a recursive flag, Unix and the path. Okay. So if I run this command, okay, I get some results. It works, great. And if I run the RJ command, okay, I get the same thing. So, okay, they, well, a little addition, but it's a little detail. RG also gives me the line number where the line shows up, and that's probably a flag in grep to have the same behavior. So little difference in default, but no big deal. So both work great. Now let's time them, and to time them, I will use a utility called hyperfine. So this is, by the way, the repo of ripgrep. Again, lots of stars, fairly recent, so that's good. And this is hyperfine, which is a very fancy benchmarking tool for the command line. So I'll use this. There are many ways that to do benchmarking. You could run the very simple default time utility, but this hyperfine utility does a much better job because it runs the command a few times, then it runs it over a certain number of times to take an average. It automatically decides how many times it will run over, and that depends on the length of the command. So if you're timing something that will take a long time, it will run it few times. If you benchmark something that goes very fast, it will do many more runs. Of course, with flags, you can customize all that, but by default, without having to fidget with and thinking about how many times you want to run over to get some average, like it has amazing default. And you can also use it to do some warm tests. So it will then do some pre-runs that aren't counted that will fill in your cache, or some cold tests. And I think that cold tests are nicer. Cold tests are after you have cleared your computer cache, because if a tool is very quick and efficient the second time you run it because it has filled in your computer cache, but the first time you run it, it takes forever, I wouldn't really call that a fast tool. It's a tool that has an efficient caching mechanism, but the first time you run it, it's still dreadfully slow. So I prefer cold tests. So that's what I'll do here. So hyperfine is the utility. This prepare flag, and this is a way to clear the cache, which on a Linux system is you can do by running echo3 and piping it to this. That's a classic Linux command to clear the cache. And then I will compare my two expressions, grep -r blah blah and rj blah blah. The -I is a way to time it even if you encounter some error messages or something. So if I'm running this, benchmark 1 is my first function, which is grep -r, etc. It goes slowly because it's doing a bunch of tests in the background. And then benchmark 2, that's my second command. So with rg, it's also doing a bunch of tests, and I'm getting the times. So grep was about 1000 milliseconds, and rg was about 70 milliseconds. So the speed up was about 14 times. So that's pretty good. And this repository I have here is not very big. So if you want to recursively search something in a very large repository, it does matter. It does make a substantial difference. Now, why is it so fast? Well, first, it uses parallelism. Grep doesn't run in parallel. RG, by default, uses parallelism. And you can customize it. You can decide how many threads you want to run. But if you don't touch any flag, by default, it will use all your available threads. So that's really cool. Then it uses a regular expression engine written in Rust that has a bunch of techniques that make it pretty optimized. And finally, by default, it will ignore any file that you have in your gitignore file, or all those ignore files from a number of classic programs. It will ignore your hidden files and directories, and it will ignore the binary files. So what's the logic behind that? Well, files that are in your gitignore might be files that you don't really care about, or there may not be text files because you put under version control only text files, or there may be outputs and results. Hidden files are all the files. They're not data. They're the files, all your settings and configuration for your machine. And running grep in binary files doesn't make much sense. So that's the default. But of course, you can change the behavior. You have the U flag, and if you run it once, then it will search your gitignore and the like. So that removes that first part. If you run the U flag twice, it will also search your hidden files, and 3 times it will also search the binary. But the default is fairly sensible. Now, another utility, so RG is intends to replace grep with some optimization, and FD intends to replace find with a more intuitive syntax and also more efficiently. And here is the repo for FD with, again, a lot of stars, up to date. And I will pass on the screen to Alex, because Alex will demo that part.
All right, thank you, Marie. Let me just share my screen. So just give me a second. Okay, can you see my screen?
Yeah. Mm-hmm.
Okay, excellent. FD is utility, which can be, so it's an open source utility, and it can be installed on your computer. It can be installed on a cluster. So I actually played with it both on my MacBook and on Cedar cluster. And at the end, in a few minutes, I'll show you how to install it on a cluster. But why use FD in the first place? Well, it's a fast alternative to find, and it's a more user-friendly, much simpler alternative to find. So for example, here I am on my local machine, and let's say I want to search for a file that has some pattern. Let's call it just pattern. It could be any substring. So normally with find, what you do is you type find. Dot means search the current directory recursively, including all subdirectories. If I'm searching for a pattern in the name, I'm going to say dash name, and then I need the quotes, and inside the quotes, I probably have something like this, right? So I'm looking for a substring called pattern, and then I hit enter. So this is what it will give me. With FD, the command is much simpler. The command is FD and then pattern, and that's it. So no flags, no quotes, no asterisk, just FD pattern, and it will produce almost the same result, but not quite the same result. So you see that the syntax, you have syntax highlighting here. So for different types of files, you have different colors. You have colors for the paths, for directories, etc. And the way FD works is, so you can bring up help for FD. You can type either man FD, or you can type FD-help. So this will give a very long page, and it's very useful because there are tons of options. So for example, you can search for size. I'm going to show you a lot of these examples in the next few minutes. But a simpler way to bring up help for FD would be to type FD-H, just FD-H, and it will show you a quick page with the usage, how you use it. So basically, when you type FD, you can usually supply the pattern. And the pattern, so by default, it uses regular expressions, but I personally don't use regular expressions very often. So I just use a pattern as, as a text substring. So FD followed by the pattern. If you want to search for files in a given subdirectory, you will need to provide the path. But with the path, you also have to provide the pattern. So let me show you. So by default, as I said, you say FD and then pattern, or let's say I'm searching for files that have slides in them. So I would type FD slides, and it will give me all the files in the current directory and the whole subdirectories that have the word slides in them, right? So now, if I want to search for slides, let's say in a subdirectory, I would do FD slides, so FD pattern, and then I provide the path to a subdirectory. For example, one of the subdirectories in this folder is intro to HPC. And so here it will search for files with slides in the name inside this folder. So if I want to search for all files inside a folder, unfortunately, this syntax would not work because FD would interpret intro to HPC not as a path, but as a pattern. So when you supply a single argument, it's going to be interpreted as a pattern. And in fact, it will tell you, if you try to run this, it will tell you. So it will detect that it's a path, not a pattern. And it will tell you that you have to use this syntax. So I personally don't really like this syntax very much because it's kind of confusing because a dot, so here dot refers to nothing in regular expression, so basically an empty pattern. But fortunately, you can use, normally dot in Unix refers to the current directory, so that's why I find it a little bit confusing. And the way I use it is I would type this. So this will, followed by the path. So FD top hat sign, so up hat sign followed by the path. And the up hat sign means that it will search for anything, right? So basically it's an empty pattern. And this will search for all files inside the intro HPC directory. All right. So now, if you want to search, so this returns files, directories, symbolic links, and other things. So if I want to search for only files, I would do something like a -tf, and this will search only for files. If I want to search only for symbolic links, I would say -tl, and this will provide only symbolic links. So there are no symbolic links. Let me actually see if I have any symbolic links right here. So yeah, so I have a single symbolic link somewhere in one of the subdirectories. Now, if you want to search for a file with a given extension, you would use the -e flag. So I would say FD -e followed by the extension. So -e has to be followed by the exact extension. So let's say I want to search for all Markdown files. Well, FD -e MD will search for all Markdown files recursively in the current directory, right? So here, all my Markdown files. If I want to search for all, let's say, Python files, well, FD -e Py will search for all Python files. Again, if you want to limit your search, if you want to search for a given pattern, let's say I want to search for, I see draw molecules, molecule, I'm going to search for draw pattern. Well, you just apply the pattern, right, along with the extension. So FD -e Py draw. Now, if I want to search for something, let's say for all Python files inside, let's say inside software carpentry subdirectory, I would do this, but of course, again, I run into the same problem where I need to supply an empty pattern. So I would supply an empty pattern, and this will search for all .py Python files in the software carpentry subdirectory. So it's just a single file. All right. So now FD behaves similar to ripgrep in the sense that it will ignore all files listed in git.ignore, .git info exclude, and a few other places. So I'm just going to paste it here because I don't have slides. So basically, everything that is listed in one of these files will be ignored by .git ignore. And the reason for this, as Mary mentioned, is to if you ignore something by git ignore, probably this is something you're not actively working on, and you probably don't want to see that that output in .fd. So if you want to override that, it's super easy to do that. So actually, let me show you an example. So the very first example I showed you, fd, where I was searching for a pattern, fd pattern. And if I do this, and then I compare this to the regular find command. So look recursively for pattern inside the name, you will see that there's a small difference. So for example, this guy doesn't show up in the output of fd. And the reason for this is because underscore site directory is included. So inside HPC carpentry Python, it's a Git repository on my laptop, and so underscore site is included into .git ignore. So if I want to still see this in the output of fd pattern, I'll just apply the -i flag. Oops, sorry, -i flag, and then it will show that directory. If you want to show everything, including the hidden files, you would also include the -H, and that will also show the hidden files. Well, there are no hidden files here, but if there were hidden files with this pattern, actually let me search without a pattern. So now you see lots and lots of hidden files as well. Well, if I scroll up, I will see lots of hidden files. So finally, fd, if you want to use fd to pipe the results into another command, there's an easy way to do that. So you would say fd, and then let's say I search for pattern. And then I would type -x. Let's say I want to pipe it into the ls command, ls-l command, right? So run ls-l on each output of the fd command. So this is the syntax. So fd pattern searches for the files, and then take all these files, and to each file, to each result of my find fd, run ls-l. And this will run ls-l on all those files. There's also an option to run a single ls-l command on all these guys. So these will produce, for ls-l, it will produce the same result. But of course, for a different command, you will see the difference. So let's say I'm searching for these guys and I'm running echo. So here it will run echo, separately apply echo to each of these files, right? So each output is going to be in a separate command. So if I apply echo once to all of them, then all of them will be treated as substrings is in a string or words in a sentence, right? So it will apply echo just once to all of these guys. So there's also a replacement. There's also even a faster way to do ls-l. What you can do is you can type fd pattern, and then instead of -x, you will type -l, and it will run ls-l on all these files. So show all the attributes like the timestamp and the file size, permissions, ownership, etc. You can also act on results of a command. So let's say you want to take all .jpeg files and convert them, let's say, into PNG files using the convert utility from ImageMagick. So the way to do this with FD would be, let's say we're searching for all files with extension JPEG, and then you apply, so to each file, you apply a convert command, where you take each file, so this is a placeholder for each file, each result in your FD output, and then you take each file without the extension, so this syntax in FD for each result without the extension, and apply the PNG extension. So what this will do, I will not run this command because I don't want to convert my JPEG files to PNG. It will simply search for all JPEG files recursively in the current directory, and for each file, it will convert that file into a similar name file without the JPEG extension, but now with the .png extension. Finally, I want to also talk about the sizes. So I find this is really useful. Let's say I want to find all files that are larger than 100 megabytes. Well, very simple syntax. Say FD. I can supply pattern, I can supply the path, but I'll just be looking for all files in the current directory recursively. So I'm going to say -s, capital S, files bigger than, let's say, 100 megabytes. Well, actually none. So let me search for files bigger than 10 megabytes. So all of these guys are bigger than 10 megabytes. And actually, I can pass them to -L, right? I pass them to -L. And let me just do head. So I display only the first 10 lines of this. So these are, the files, all of these guys are bigger than 10 megabytes. And as you can see, they're all bigger than 10 megabytes. So finally, I just want to very quickly mention that you can install find FD, very easily. So let me start Emacs. Emacs here. So I will paste the command for installing how we install it on a cluster. And it works very well on a cluster as well. So on a cluster, for example, you're logged into Cedo or any other cluster in Compute Canada, you will need to load the Rust module because FD was written in Rust. And then you will use the utility. So there's a Rust. So loading this module will give you access to the Rust package manager cargo, and you'll just run the command cargo install fd.find, and it will install fd into the .cargo folder in your home directory. And then to be able to use it, all you need to do is just you'll add these. So the bin subdirectory inside .cargo in your home to your path in, let's say, your .bashrc file or wherever you typically modify your path. So this is how you install it on the cluster. And normally, so I'm not going to show you benchmarks, but if you go to the homepage of FD, let me just paste it here. Actually, I'll paste it into the chat. So if you go to the homepage of FD, there are some benchmarks there, and you see that normally FD runs some like 3 or 4 times faster than the usual find command. All right, so I think I will stop the share here, and we'll pass the screen back to Marie.
Okay, thank you, Alex. Yeah, FD is definitely much faster than find, the same way that RG is much faster than grep. And the utilities that I showed previously, I didn't show you how to install them on the cluster, but they're also all fairly easy to install on the cluster and fairly portable. Now, so, and also as Alex was presenting, I fixed my Git mess that I created by switching branch when there were a lot of unstashed things everywhere. And so I'll go back to LazyGit at the end to actually show you how it works, because I really messed that one up. Anyway, next tool I want to talk about is Pass. It's a command line password manager for Unix systems. And here is, so it's not on GitHub, so I can't show you the GitHub repo, but this is the page with the instructions that I'm linking here. And it uses GNU-PG for encryption. So basically what it does is that it creates some file tree, and it creates for each of your password a file that is encrypted by GPG. And it's super easy to navigate, super easy to do. And Pass, in fact, is simply a script. So you can, now that you are familiar with bat, we'll use bat instead of cat to look at Pass, and you can see that it is a bash script. So it's that means that it is extremely flexible. It can be used in combination with scripts, other utilities. There are many extensions written for it. It has integration with Git. So it's really cool. And here are the main commands, and I'll demo it. So if I go to my home directory and I run Pass, I'll get an error message because I don't have any password store. I mean, I did have one, of course, but I cut it somewhere else. I moved it somewhere else temporarily and will move it back, because since it's just a tree with a bunch of things, you can copy it, you can move it, it's very flexible. But by default, it lives in your home directory. So the first command is to run pass init. And because it uses GPG for encryption, you need to pass your GPG ID. So if you don't use GPG, you will have to first look into GPG, install it, set it up, and learn to use it. So I'm not going to talk about that part here, but my ID for my GPG key is my email address. So if I run this, I initiated a password store. So now if I run pass, you can see that, okay, there's a password store, but it's empty. And if I actually look at what has happened in my home directory, now I have this .password store directory, and this is where all of my passwords will live, all of those GPG files. Okay. So the first thing that you might want to do is to insert some password that you have already created for some site. So the way you do that is that you run pass insert, and then the name of the site. So that can be, for instance, I don't know, skype.com, zoom.ca, gmail.com, whatever. And then either your email address or use your user ID, but whatever you use to log in on that site. And then it will ask you for your password. So let's say that my password for that site is utterly secure. My password is 123. Okay, so it will ask me to redo it. So I retype it. Okay. So now if I run pass, you can see that in my password store for somesite.ca, I have one password that is associated with my email address. I can, of course, retrieve it. And to do that, I run pass somesite.ca / my email address. And the slash comes from the fact that it's really just a tree. Like if I go back to ls-il, and then I go to the password store, now you can see that I have somesite.ca. And if I look into that, you can see that there is a GPG file that has been created with my email. And so inside that GPG file, there is the password. But to go look at it, you don't have to look for it in the file system. You can run pass somesite your email, and it will print it on screen. So that was my Uber secure password 123. Now, maybe you don't want to print your password on screen. It's not the most secure thing. Maybe you don't like it. So in that case, you can run the -c flag, and instead of printing it, it will copy it to your clipboard. So now it doesn't show on screen, but I can go pass it wherever I want. There. Now, so that's if you already had a password, or if you want to set a password the way you like it. But something that is a lot nicer is to generate automatic passwords. And the command for this is pass generate. And then, so let's see, for instance, I have some newsite.com, and this time I log onto this one with my user ID. When you use pass generate, you need to set the number of characters, random characters that you want pass to use. So for instance, I want 12 characters. So now it has automatically generated this random password, and it has created this new entry. So now for newsite.com, under user ID, I have this password. Here again, maybe you don't want to have that password ever printed on the screen. So you could run the same thing, but with -c. It doesn't matter where you put the flag, but let's put it here. And let's create a new one. So maybe this one is with your email again, and this is some other site. So other site. Okay. So here I'm running the same command, but of course for another site, and I'm using the -c flag. So here again, it's created, but now it never gets printed on the screen, but for 10 seconds, it's in my clipboard. So during 10 seconds, I can print it, and then it disappears. And the time during which it remains in your clipboard, of course, is adjustable with some flags. So now if I look at my password store, I have this. You can, of course, remove a password with pass rm, and then so let's see, it was no, it was newsite was with, it was newsite.com user ID. If I want to get rid of this one, are you sure you want to delete? Yeah, okay, this is outdated. I want to delete it. Okay, so now I've removed that one. But because there's no magic to it, this is just a tree with some files, some GPG files that contain your passwords. You could also go manually to your to the .password store directory and use the rm command. It's just very simple, really cool, very convenient. And some sites, they are disappearing, but some sites ask for passwords that don't contain special character. Well, there is a command for that. You can, it's the -n flag, so you can use that. And let's create yet another one. So last site is that really not so great site that doesn't accept special character. So I'm passing it with n. Now it's created, and indeed you can see there's no special character in it if I print it. So that's pass. Very simple, but really convenient. Now, before I go into the Emacs things, I want to go back to LazyGit because I really messed that one up. So I went back to my main branch and I fixed what I had done. So you can see that you can see the various branches. With space, you can switch to them, but I'm not going to do it again because my Git repo is very messy. I'll show you what a normal workflow would be. So you can, if you press the space bar, stage an entire file or unstage an entire file. Red, it's unstaged. Green, it's staged. So, okay, so that's convenient, but you can do even more fancy than that. You can do a line by line stage if you press enter and then space bar to various things. So for instance, here, okay, I removed this stupid line and then I added a bunch of things. I could just do all at once and make a commit with all that. But maybe I want to do something more sophisticated. I want to remove this thing. So those are my stage changes and those are my unstaged changes. And then with a C, I can type a commit message and do my commit. So remove stupid line, enter. So now you can see that here in the commit section here, there is this new commit. I can go see it. Okay, what I've done here is to remove that stupid line. The two commits here have a different color. The hash is red instead of orange. That's because I haven't pushed them. And you can see that in the status, I am now 2 commits behind the remote. I can push that with a capital P and now it's pushing. So it's sending that to the remote. And now, okay, you can see 0, 0. So I'm in sync with the remote and they've changed color. So I can do commit an entire file. So add lots of code. And here again, I can, okay, so let's see, I have various things. Again, you can change the size. So maybe I want to only stage those elements that I have added, but not the other ones. So if I go back to the main window, you can see that now what is staged, I've just staged the changes of values, but I haven't staged some other code. So now I can change values training. Boom. Now I've made another comment. So commit. So you can see that this is all extremely convenient. You can visually see the diff. You can do some staging line by line, all things that are pretty tedious, honestly, to do directly from the command line. So that's pretty cool. And you can see them. And there's a lot of my stash that I created earlier. There's a lot of other things that I'm not showing, but I just wanted to show how really easy all of that is. And there's a little added bonus. If you use diff so fancy, which is a really cool way to show your diff, including Git diff in a nicer way, you have an even nicer thing. So let me go to my config file for LazyGit. I'm activating Git diff so fancy, and I'm using diff so fancy because I like it, but you can use any other utility you want. Now, if I rerun LazyGit, I have diff so fancy in my diffs. So what that does is that I have in a very clear way the name of the file that is modified, all the very obscure location lines that are useful for Git but not useful for humans are gone. And well, there's no example here, but I'll try to find an example here, right? So in the normal Git diff, you see in red lines that have been removed, in green lines that have been added. But here, diff so fancy, in addition, highlights exactly what has been changed. So you don't have to visually squint and wonder what has changed between that one and that one. It's all highlighted. So it's really visually very nice. So, and then, okay, let's do a last pushing to, so it's really amazing. And this is just like like general workflow to stage and commit, but there's so much more to it. And as you can see, it's just instant. It's super easy to install on the cluster or just anywhere. So, okay. So now, for Emacs users, non-Emacs users, you are welcome to run away. I wanted to show two packages that I think are pretty cool. The first one comes with Emacs. You don't have to install it, and it's TRAMP. That stands for Transparent Remote Access Multiple Protocol. And all it is really, it's a package that allows to edit remote files as if they were local, or files from other users as if they were yours. So why would you want to do that? Well, Emacs users love Emacs because they love to customize everything. So in Emacs, you change anything you want, you make Emacs the way you like it. So that means that you have what's called an init file or initiation file with all your customization that can become very sophisticated, and you install a number of Emacs packages that allow you to do all sorts of neat things. Now, if suddenly you want to edit a file that is on the cluster, you could SSH to the cluster, run Emacs there and edit it there, but you're going to revert to default Emacs, which is pretty horrible. Unless, of course, you have set up Emacs on the cluster, but of course you have to do that. It's some work. With this, you can, instead of SSHing into, instead of running an SSH command to get to some remote machine and then opening Emacs there, you run your Emacs on your machine with your configuration, your init file, your packages, and you can, thanks to TRAMP, which under the hood uses RSH and a number of other tools, create or edit files remotely. And this used to work very smoothly and very easily on the computer clusters, but I won't be able to demo it now because, as those who use our clusters know, recently we have increased the safety of the clusters. So now you have to have a YubiKey or some app on your phone that allow you to enter some OTP password, and TRAMP doesn't play well with that. So unfortunately, we have to figure out how to use that more smoothly. But what I can demo is how you can use it to edit files with admin privilege, because your configuration file for Emacs is under your username, of course. And if you use sudo Emacs and then some file, suddenly you will open Emacs with the configuration of root. So you're losing all of the cool things you're used to, but thanks to TRAMP, and you can use TRAMP from within Emacs or from the command line, you can edit a file with admin privilege with all of your configuration. So the way that works, let's see, I'll run the sudo. Okay, so you would run Emacs. I'm using Emacs client -C because I have an Emacs server running, and this is just a way to open a new Emacs window, but you could just have Emacs here. And then the syntax is to have /sudo ... and in between the, colon, and in between those columns, you could have a server name and then the path of the file. So you can see that the file is in ets. So it's a file that requires root privilege. That root privilege, I'm accessing it thanks to this. So instead of running sudo Emacs, blah, 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 I'm running Emacs with this syntax, and it opens, I have all of my regular key bindings, configuration, and etc. Super easy. From within Emacs, you would do Control-X, Control-F, which is the regular command to find files. And then you'll have to type sudo ::, and then it was at, I don't remember what the command was. It was, oh yeah, it was, okay, sorry. So, sudo colon, and it was in ets, where was it? SSH, SSHD, it was this file, config. Okay. And from within Emacs directly, I have access to some files with root privilege with that. So it's extremely convenient. And I hope to find a way to be able to use it with the Complete Canada clusters, because it's really, really convenient, and we have to figure that out. Because the multi-factor authentication has made it, it's broken it, but we'll figure it out. And then the last tool that I want to show you is called Helm. So this one, you have to install it. So this was the wiki for Tramp mode for Helm. The page is over here. As you can see, it's updated frequently. 3,000 stars looks very little compared to the 30,000 and the like that we saw for tools such as RG and FD and the like. But considering that the Emacs user community is only a very small subset of the Linux community, this is actually pretty damn good for Emacs. So it's a great package. And what it does is that it provides an incremental completion and narrowing framework for any search application in Emacs. So what does it mean? It means that whenever you're searching anything in Emacs, so that can be grep, locate, find, searching in your email, searching, any kind of search, it provides this visual window, and as you start typing, it shows all the possible completion, and the more you type, the more it narrows down to your completion, and it's really, really cool. So I'll demo it. So this is my init file that I have open here, and I'll show you a number of search tools for which I have set Helm. And by default, Helm has a number of search tools that it comes with, but the vast majority of search and similar packages that are built automatically create an Helm integration because Helm is so very popular. So the first thing is Helm occur, which is the equivalent of grep. Like I'm going to search some words in my file. So for instance, global. And so you can see here, so my file is on the right. And on this buffer here, which is the Helm buffer, I have all, it's the equivalent of a grep output. I have all of the lines in which global show up with the line numbers on the left. And as I move up and down, I can see on the right what's around. So it's super convenient because it's the equivalent of having grep and at the same time being able to see what's around. As I keep typing, it narrows down, it removes anything that doesn't fit. So that's what's called a completion framework. And once I have found some line I'm interested in, if I press enter, I'm moving to that line. So it's just really great. Another one is Helm task switch, and it allows you to navigate your buffer, recent files, and a number of other things. For instance, those are my open buffers, so my open files. This is Emacs here, but I can look at script, and if I press Control J, and it's written at the top, but you might not see it very well, it's going to show it. Emacs, I can go back, config, and here again there is completion. So if I were to type script, it will narrow down to what matches that selection. So buffer, those are files that are open. Recent, those are files that have recently closed, and I can jump to that. Windows, those are all of my windows, so that includes utilities that are outside of Emacs, or I can even create a brand new buffer. So it's just really cool. Another one So that's just for the recent files. So it's a subset of the ones I showed previously, and I can reopen one, for instance, this. I'm opening it. If I run Control G, which is the way to escape anything in Emacs, I go back to my .emacs. If I press enter, I'm going to enter my Z shell history. Let's escape. Okay. Then you can have your mark ring. So in Emacs, a mark ring is whenever you jump within a file in Emacs, under the hood, Emacs saves your locations. And you can navigate your mark ring just with key bindings, but you're kind of in the dark a little bit. Well, with Helm mark ring, you see your mark ring. There's a global one that includes all of your open files, and one just for the file from which you launch this command. You can easily see the various locations, as with other Helm type searches, you can move around and it shows you the various locations in your file. Control G will escape, and so I'll go back to where I was. Enter will put me to that location, and of course there is narrowing search, so I can narrow it down. There is control mark ring, already did it. Control, there is a kill ring. So whenever you copy or cut something in Emacs, it goes into your kill ring. In a lot of applications, you can copy or kill and then paste only the very last thing. Like you copy something, you can paste it. But if you copy one thing and then you copy another thing, you can only paste that other thing. There's only one thing that gets kept in the memory of the application. So there are some tools that allow, some Unix tools, for instance, that allow you to retrieve access of your clipboard. I have one such tool, for instance, that's like I have this little pop-up window that allows me to navigate my clipboard. So those are the passwords we generated with pass, etc. But this is a way to access the same thing within Emacs. And so I can select some of the things I have copied or pasted, and then I can go past them wherever. So that's pretty cool. I can search my emails, but of course for that you have to use Emacs for your emails, but from mountain condition. Okay, so here again, I can navigate, and with enter, it's going to open that particular email. Oh, not sure what happened here. Yeah, sorry. Let me reopen Emacs. Okay. You can. Oh, I'm in the wrong window. Oh. You can search for Unicode character, for instance, or let's say crying, and Control G insert character. So if I press Control G up, it's gonna insert it. Okay. Etc. etc. I mean, there are many more examples, but we're out of time. I'm already 10 minutes past. I'm going on and on and on because I find Helm absolutely wonderful, but I guess non-Emacs users have probably already left, and Emacs users must have gotten the point. But it's just very cool. Where is my, yes. So it just, maybe one last one, you can search some colors. So for instance, you're looking for some blue, let's say maybe royal blue. Okay, royal blue number 3. So Control G kills the hexacode. So if I run Control G And then I can just pass, that's the Xcode of the stuff I have selected. So it's just super cool. So that's that. That is the last tool I wanted to show. And there are a number of screenshots of various things that you can do with Helm. But because any search-like thing can run with Helm, the number of applications is pretty much endless. Other questions on any of these tools?